In this lecture, I'm going to walk you through different aspects that would affect a climate. Latitude is the first factor that we're going to talk about. Remember, latitude are the horizontal lines on a globe. So if this is my Earth, the 0 would be the equator, and the top and the bottom would be 90 degrees, which would be our north and south pole. So the lower the latitude, meaning the closer to the equator it is, the more solar radiation an area is going to receive. More radiation means higher temperatures, it's going to be hotter. So if we take a look at some solar radiation beams coming in, notice they're all the same width. So they're equally spread apart. As they come to the surface of the Earth, if we're near the equator, this red line shows you the surface area that they are covering up on the surface of the Earth. So at the equator, notice the surface area is relatively small. So that means a high concentration of solar radiation. As we move more towards the North Pole, so like up in Alaska, Canada, that same amount of radiation is spread out over a much larger surface area. So it's going to get colder at the poles. So now I'm going to have you take a look at locations A, B, and C and predict what kind of temperature it's going to be. To make things a little bit easier, if we're going to take a look at specifically just latitude, between 30 degrees north and 30 degrees south, this area is all going to be hot because they're receiving a lot of solar radiation, so they're going to be hot. Between 60 and 30 degrees, we're going to call this temperate. It's a temperate climate. Same thing in the southern hemisphere. So now I want you to take a look at letters A, B, and C and just focus on latitude. What would their temperatures be based off of their latitude? A is between 30 degrees north and 30 degrees south, so that would be hot. B is between 30 and 60, so that would be temperate. C would be cold. Okay, we need to pay attention to global winds because global winds will bring certain temperatures, but also moisture or the lack of moisture. If the wind is coming from an ocean, it would bring moisture. If it's coming from land, it'll bring dry weather. We also have to look at mountains. If it is going up a mountain, we're going to get more rain. If it's coming down a mountain, it's going to be hot and less rain or very dry. We also need to pay attention to the global wind patterns, if it's rising or sinking. If it's rising, we're going to get rain. If it's sinking, we're going to get dry air. Okay, this is just a review. We have our northeast trade winds and our southeast trade winds, our westerlies and our polar easterlies. So if we're looking at mountain ranges, we have to pay attention which way they're going. If the wind's coming off of the ocean, we're going to get more humidity near coastal regions. If I'm here and the wind's coming from the land, I'm going to get more dry air. Remember, our like continental tropical air masses are very dry. But we also have to pay attention to the latitudes. Latitude 0, at the equator, we have rising air. That rising air is going to cool down, condense, and rain, so we have a lot of rainforest on our 0 degree latitude. Doesn't matter if it's on the coast or inland. We're going to get a lot of rain on that 0 degree latitude. At the 30 degree latitude, we have a high pressure system, which means air is sinking. That's going to stop our cloud formation, so the 30 degree latitude is going to be very dry. The only exceptions might be a coastal region right next to an ocean. 60 degree latitude, you see rising air. It's a low pressure system, so we have our temperate rainforest at our 60 degree latitudes. And at our north and south pole, we have sinking air. That would be a high pressure system bringing very dry air again. Okay, now let's take a look at examples D, E, and F. D, if you see the wind is coming off the ocean towards D, so what kind of climate would you think that would have? I would think D, in terms of moisture, would be more humid because it's near the coast. So you have moisture coming off the ocean towards D. What about temperature for D? It's between 30 and 60. So it's going to have a temperate climate. E. It's also between 30 and 60, so it's going to have a temperate climate. And the temperature, the moisture, I would say sort of a moderate moisture, MOD, moderate, or you might see the term subhumid or subarid. I think in a lab I'm going to have used the term subhumid. The reason why it's not humid is because first, it's not really close to the coast, and second, our wind is coming from the land. It's not going off the ocean from the land. Now, if E were right on the coast, then yes, it would be humid. But it's far enough inland and the air is coming from the land that it's not going to have a lot of moisture. You could even make a case for it being arid. Arid meaning dry. And the last one, F. F is near the equator, so that's going to make it hot. I would say it's on the equator. And that since it's on the equator, we have this rising air. This rising air is going to cause it to rain. So it's going to be humid. Next, we're going to talk about ocean circulation. Remember, oceans and water, they have a high specific heat, which means they don't change temperature very easily. So when if it's at the equator and takes a long time to heat up, it's also going to take a long time to cool down. So for coastal cities, especially in the temperate region, in the summertime, the water is going to be colder than the land. So it's actually going to cool the land down. So our summers are not going to be as hot as the same city would be if it were farther inland. In the wintertime, our oceans are warmer than the land, so it's going to warm the land. So it's going to bring our winter temperatures up a little bit. So our temperature range, the highest temperature minus the lowest temperature, is going to be very small. It's going to have a small range. So we're going to call that a mild climate. Warm ocean currents come from the equator because that's where they're being heated. So the eastern part of the United States is being warmed by what's called the Gulf Stream, this warm current coming up. If you go to California, if I go to New Jersey and I go straight over to California, I'm going to have a very different swimming experience. It's going to be much warmer here in New Jersey than it will be over here in California, even though if I'm on the same latitude line. The reason for that is because in California, the water is coming from the north and it's going to be cold. But if I were to look at a city on the coast here and compare it to the city in the middle of the United States, the coastal city is going to have a much more mild climate because it has a smaller temperature range. The city in the middle of the continent is going to have hotter summers and colder winters. It's going to have a much larger range. Okay, now let's take a look at H and G in terms of temperature of the ocean. If we take a look at G first, since that comes first in the alphabet, what would our temperature be like? It's between 30 and 60, so it would be temperate. But we may call it a mild temperate. And what about the moisture? It is right on the coast, so we would call that humid. H. H is also between 30 and 60, so we call that temperate. And the temperature is temperate, and the humidity would be arid, which means dry. It's arid because it is in the middle of the continent, so there isn't any ocean there to provide the moisture. So we're going to have a continental air mass. And if you remember, continental air masses are dry. Okay, the next factor is altitude or elevation. We've talked about as air rises, it cools down. That convective cooling, as it rises, the air pressure decreases, and that causes it to expand and cool down. So when we're looking at mountain ranges and air's rising up over mountain ranges, it's going to get colder as it goes up. On the downside, as it's going down the side of a mountain, the opposite is going to happen. It's going to warm up. An interesting thing, it actually cools down slower as it's rising up than it warms up. So it warms up a lot faster as it's coming down the same elevation change as it does going up. So that's going to give you a warmer or hotter side on one side of the mountain than the other side. This is called the rain shadow effect. So for the rain shadow effect, you have two sides of the mountain. You have windward. This is the side of the mountain that the air is rising up and over. So if this is my mountain, and my wind's coming this direction and rising up, this would be the windward side of the mountain. As air sinks and moves away from the mountain, this is called the leeward side of the mountain. So as air rises, it's going to first cool down. Once it cools down, then it can condense and form a cloud. Once it forms a cloud, then it can rain. So we have lots of rain on one side of the mountain. As the air sinks, it's going to warm up on the other side, and there is no more moisture. So we often get deserts or very dry climates on the leeward side of the mountain. Plus, it's going to be hotter on the leeward side of the mountain than it will be on the windward side of the mountain. If you take a look at this diagram, this is at the same elevation. So over here we have an elevation of about 1,000 meters high. The temperature is going to be 10 degrees Celsius. At the same 1,000-meter high on the other side of the mountain, our temperature is going to be 18 degrees Celsius. So it's much hotter on the other side of the mountain, even though it's the same elevation. Okay, let's take a look at the mountains. Now my V's really should be upside down V's, but it did not import properly. But my V's, or my upside down V's, are supposed to represent mountains. Now, when we're looking at mountains and we're talking about climates, we're going to assume that these are very large mountains and they're going to be really high up. So these aren't just little rinky-dink mountains that we would get in Pennsylvania. Okay, so let's take a look at I, J, and K. We have to pay attention to the winds. So between I, J, and K, looks like they're all in the northeast trade winds. So our winds are basically going this direction. So if we take a look at K, K would be on what wind? Would that be on the windward or leeward side? K would be on the windward, J would be on the top of the mountain, and L would be on the leeward side of the mountain. So if we take a look at I, here's where it gets a little tricky. Let's look at I in terms of temperature without the mountains. I without the temperature, or without the mountains, is in the hot zone. Since I'm on the leeward side of the mountain, it would get even hotter. So we're just going to call that hot. We're not going to distinguish between hot and really hot. So I would be hot. Now, if we're in the temperate zone, if I have a spot over here, actually over here, this would be our leeward side. This would normally be temperate between 30 and 60, but because we're on the leeward side of the mountain, that would then make it hot. Okay, I, going back to I, what is the moisture like going to be for I? It is on the leeward side of the mountain, so it's going to be arid. Next up, J. J would normally be hot because it's between 0 and 30 degrees 90. Between 0 and 30 degrees north. However, it's on top of the mountain. So it's even if you're at the equator and you're up high on a mountain, it's going to be cold. Can cold air hold moisture? Nope, not very well, so it's going to be arid. Now let's take a look at K. K is between 0 and 30, so that would make it hot. It is on the windward side of the mountain. So as the air rises up the mountain, it's going to rain down on K. So even though it's on the middle of the continent, we're still going to get rain. So we call that humid. Okay, let's take a look at, let's do another example while we're here. Let's take a look at Z, X, and W. Now we have to pay attention to the winds because our winds are coming from a different direction. You must pay attention to which way the winds are coming from. So the winds are now going this way. So Z is now at my windward side. So Z would normally be temperate since it's between 30 and 60. It didn't go up the mountain yet, so we still call Z temperate, and it's going to be humid because it's on the windward side of the mountain. W, still going to be cold because it's up high on the mountain, so it's going to be cold and arid. X, this is where it gets a little tricky. Normally between 30 and 60 it is temperate, but because it's on the leeward side of the mountain, it's going to be one category hotter. So X would be hot just like K would be hot. Okay, I touched based on high and low pressure system when I talked about the global wind patterns. Remember, high pressure is where we have sinking air, and sinking air is going to be really dry. We have high pressure systems at 90 degrees latitude and 30 degrees latitude. Low pressure systems is going to cause air to rise. Rising air will cool down, condense, and rain. And we're going to find a lot of rainforests at the 0 and 60 degree latitude. 0 would be our tropical rainforest, 60 would be our temperate rainforest. 30-90 would be your deserts. So the southeastern part of the United States would be much like 30 degree latitude, is going to be hot and dry. And 90 is going to be your cold deserts. So again, 0 is your rising air and rain, 60 is rising air and rain. 30 degrees is sinking and dry, 90 degrees is sinking and dry. Okay, now let's take a look at L, M, N, and O. Specifically, let's start with L. L is between 0 and 30 degrees latitude, so that makes it hot. It is on the equator, which is a low pressure system, so it will be humid. Notice at the equator here we have rising air, and it's going to be wet, moist air. Next up, M. What would the temperature of M be? It's going to be hot because, I guess technically it's still between that 0 and 30 latitude, but also at the 30 degree latitude we have sinking air, and sinking air warms up just like on the leeward side of a mountain. Sinking air warms up, so the 30 degree would be hot. And what would the humidity be like? It's going to be arid, meaning dry, because you are in the middle of a continent, plus you're at that sinking air, so it's sort of like a double whammy, so you're going to get a lot of deserts there. N. N is between 30 and 60, so we're going to call that temperate. And we have rising air. Rising air, we give it a humid. Now, if it were a little farther to the south, that low pressure system at 60 degree latitude wouldn't affect it, so it'd be dry. So something here where the red dot is would be dry or arid. Something here would be dry or arid. But since it's on that 60 degree latitude, that would give it a humid climate. And last, O. O is between 60 and 90s. That's going to be cold. Now for the moisture, I would accept two answers here. It's cold, and cold air does not hold moisture, but also the winds are coming right off the ocean onto the land. So normally cold air is dry, but because we have wind coming right off of the ocean, that's going to bring some moisture, but it's not going to be very humid because it's not warm air. So we're going to call that in the middle. So subhumid. I would also, if you said subarid, I would accept that. Or if you said moderate, something in between, I would accept that.